This chart here is not the growth in AI computing or anything like that. This is the growth of NVIDIA's stock price since 2018. You can see it has shot up from just $39 all the way to $900, a 23x increase in the price. This chart also has nothing to do with like AI computing or the improvements in AI throughout the years. This is NVIDIA's sales year over year. So you can see an impressive exponential growth, just crazy demand for NVIDIA's hardware. Now, on Monday, NVIDIA had this 2024 GTC AI conference. This is mostly a conference for developers and for NVIDIA to really showcase their cutting-edge products. So I'll play you some clips from the conference in a second, but what Jensen Huang, the founder and CEO of NVIDIA, what he kind of mentions in the conference could be very technical. So the point of this video is to really break down what he says in the conference so that you can easily understand what he's saying and what this means for the future of AI and robotics. Even if you're not very technical, I would also recommend that you watch this. I'll try to make it as easy as possible for you to understand so you'll know what to expect in the world of AI in the short-term future. With that, let's jump into the first clip.
Blackwell is not a chip. Blackwell is the name of a platform. People think we make GPUs, and we do, but GPUs don't look the way they used to. This is Hopper. Hopper changed the world. This is Blackwell. It's okay, Hopper. You're very good. 208 billion transistors. And so you could see, I can see, there's a small line between two dies. This is the first time two dies have abutted like this together in such a way that the two dies think it's one chip. There's 10 terabytes of data between it, 10 terabytes per second, so that these two sides of the Blackwell chip have no clue which side they're on. There's no memory locality issues, no cache issues. It's just one giant chip. And it goes into two types of systems. The first one is form-fit-function compatible to Hopper. And so you slide out Hopper and you push in Blackwell. That's the reason why one of the challenges of ramping is going to be so efficient. And so this is a Hopper version for the current HGX configuration. And this is what the second Hopper looks like this. Now, this is a prototype board. And Janine, could I just borrow? Ladies and gentlemen, Janine Paul. And so this is a fully functioning board, and I'll just be careful here. This right here is, I don't know, $10 billion. And the way it's going to go to production is like this one here, okay? And so you're going to take this. It has 2 Blackwell chips and 4 Blackwell dies connected to a Grace CPU. What's amazing is this computer is the first of its kind where this much computation, first of all, fits into this small of a place. Second, it's memory coherent. They feel like they're just one big happy family working on one application together.
All right, so arguably one of the biggest announcements that he made was this Blackwell chip. Now, he compares it to the Hopper chip, which, it looks tiny in comparison with this new Blackwell chip. But I just want to talk a bit about this Hopper chip. It's already state of the art. This is the most demanded GPU out there. The Hopper chip is a core component in this H100 GPU, which is like the most demanded commodity in the tech world right now. So this is just an estimate and it's in 2023, but here it's showing like how many H100 shipments are estimated to be requested by these top tech companies. So you can see both Microsoft and Meta, they're guessing that they demand 150,000 of these H100 GPUs. And then Google, they are kind of building their own Tensor Core GPUs, so they don't need as much, but also 50,000 from them. Amazon, 50,000, etc. So these H100 chips are already in huge demand. And again, I'm only talking about this chip here, the predecessor to this one, which he just announced. This chip has sold for $30,000 to $40,000 and even more sometimes in secondary markets, just because they are in such high demand. Now, fast forward to Monday, NVIDIA announces this, the Blackwell chip. This chip by itself already outperforms this one by a lot. But if you add this to their GP200 superchip, the results are even crazier. So this is the GP200 Grace Blackwell superchip. It basically contains 2 of these Blackwell chips plus a Grace CPU. This gives a 30 times higher performance and 25 times less energy than this previous Hopper chip. Just think on that for a second. If you're familiar with Moore's law, it's basically the observation that the number of transistors in a chip doubles every 2 years. But right now, we are totally just exceeding this. This announcement from NVIDIA about this GP200 superchip just blows Moore's law out of proportion. Again, here's a chart showing how much improvement this superchip offers compared to the Hopper chip, which is already really good. So it's 30 times higher performance. We're not even doubling performance every 2 years now. And again, this Hopper chip is already like state of the art. This is demanded by the top tech companies in the world. But this GP200 superchip just blows it out of proportion. Now, Jensen did not mention the pricing of this superchip for a single Blackwell chip. He did jokingly say it's worth like billions of dollars. But yeah, as far as we know today, there's no pricing details released yet. And by the way, the Blackwell chip is named after David Blackwell, who is an American statistician and mathematician who made significant contributions to game theory, probability theory, information theory, and statistics. He's the first African American inducted into the National Academy of Sciences. Also the first African American full professor with tenure at UC Berkeley. Unfortunately, he has passed away in 2010. So Jensen later goes on to explain the architecture of this chip and why it's so powerful. The new design has so many transistors that it's too big for conventional designs. And a transistor is basically a tiny switch that gives semiconductors their ability to store and process information. And so instead of like a traditional chip design, they actually had to glue 2 chips together through a connection that ensures they act seamlessly. And there's not much info on how they will produce this yet. And of course, the price, they didn't release that. But he did mention that they're going to work with their manufacturing partner, Taiwan Semiconductor Manufacturing, and use their 4NP technique to produce the product. All right, so we covered a few things here. We covered the singular Blackwell chip, as well as the GP200 superchip, which includes 2 Blackwell chips and a Grace CPU. Plus, he also talks about this.
We created a processor for the generative AI era. And one of the most important parts of it is content token generation. We call it, this format is FP4. The rate at which we're advancing computing is insane, and it's still not fast enough, so we built another chip. This chip is just an incredible chip. We call it the NVLink switch. It's 50 billion transistors. It's almost the size of Hopper all by itself. This switch chip has 4 NVLinks in it, each 1.8 terabytes per second. What is this chip for? If we were to build such a chip, we can have every single GPU talk to every other GPU at full speed at the same time. You can build a system that looks like this. Now, this system is kind of insane. This is one DGX. This is what a DGX looks like now. Just so you know, there are only a couple, 2, 3 exaflops machines on the planet as we speak. And so this is an exaflops AI system in one single rack.
So basically, if this superchip does not offer enough computing power for you, again, this is already like 30 times better than the best state-of-the-art chip out there right now, the Hopper chip. You can also stack these together into something like this. And this is called the GP200 NVL72. So these things are like cartridges that you insert into this tray. And so one tray consists of 2 Grace CPUs, which is this black thing here, and 4 Blackwell GPUs, which are these 4 gold chips over here. So that's just one cartridge. So you stack all of these into this computer, which basically allows you to perform a ton of computing in real time. He also mentioned this NVLink switch chip, which is what you see here. So there's like 4 of these, I'm guessing, in one tray or one cartridge, which you slide into the computer. And what these switches do is they ensure a seamless integration with the CPU, the GPU, and all the trays inside this stack. as you can see here, you can kind of just insert these here and then stack them together. And then it also offers a liquid cooling system, which delivers 25 times lower cost and energy consumption. For those of you who may not be too familiar with liquid cooling, it's basically a more efficient way of cooling a system. So you can either use like fan-based cooling or liquid cooling. And the advantages of liquid cooling is that you get enhanced cooling performance. Liquids can dissipate heat more efficiently than fan-based cooling. It's also a lot quieter, and it also allows for stable temperatures even when pushing GPU to its limits through overclocking. This chart that NVIDIA shared is also just mind-blowing. So they're comparing the compute power in the past 8 years, so in 2016 to 2024. And, they're showing us it's 1,000 times increase in performance with this Blackwell superchip.
I want to thank some partners that are joining us in this. AWS is gearing up for Blackwell. They're going to build the first GPU with secure AI. They're building out a 222 exaflops system. We're CUDA accelerating SageMaker AI. We're CUDA accelerating Bedrock AI. Amazon Robotics is working with us using NVIDIA Omniverse and Isaac Sim. AWS Health has NVIDIA Health integrated into it. So AWS has really leaned into accelerated computing. Google is gearing up for Blackwell. GCP already has A100s, H100s, T4s, L4s, a whole fleet of NVIDIA CUDA GPUs. And they recently announced the Gemma model that runs across all of it. We're working to optimize and accelerate every aspect of GCP. We're accelerating Dataproc, which for data processing, their data processing engine, JAX, XLA, Vertex AI, and Mujoko for robotics. So we're working with Google and GCP across a whole bunch of initiatives. Oracle is gearing up for Blackwell. Oracle is a great partner of ours for NVIDIA DGX Cloud, and we're also working together to accelerate something that's really important to a lot of companies, Oracle database. Microsoft is accelerating, and Microsoft is gearing up for Blackwell. Microsoft and NVIDIA has a wide-ranging partnership. We're accelerating, CUDA accelerating all kinds of services when you chat, obviously, and AI services that are in Microsoft Azure. It's very, very likely NVIDIA's in the back doing the inference and the token generation. They built the largest NVIDIA InfiniBand supercomputer, basically a digital twin of ours, or a physical twin of ours. We're bringing the NVIDIA ecosystem to Azure, NVIDIA DGX Cloud to Azure. NVIDIA Omniverse is now hosted in Azure. NVIDIA Healthcare is in Azure. And all of it is deeply integrated and deeply connected with Microsoft Fabric. A NIM, it's a pre-trained model, so it's pretty clever. And it is packaged and optimized to run across NVIDIA's installed base, which is very, very large. What's inside it is incredible. You have all these pre-trained, state-of-the-art open source models. They could be open source. They could be from one of our partners. It could be created by us, like NVIDIA Moment. It is packaged up with all of its dependencies. So CUDA, the right version. cuDNN, the right version. TensorRT, LLM, distributing across the multiple GPUs. Triton Inference Server, all completely packaged together. It's optimized, depending on whether you have a single GPU, multi-GPU, or multi-node of GPUs. It's optimized for that. And it's connected up with APIs that are simple to use. These packages, incredible bodies of software, will be optimized and packaged, and we'll put it on a website. And you can download it. You could take it with you. You could run it in any cloud. You could run it in your own data center. You can run in workstations if it fit. And all you have to do is come to ai.nvidia.com. We call it NVIDIA Inference Microservice, but inside the company, we all call it NIMS. We have a service called NeMo Microservice that helps you curate the data, preparing the data so that you could teach this, onboard this AI. You fine-tune them, and then you guardrail it. You can even evaluate the answer, evaluate its performance against other examples. And so that's called the NeMo Microservice. We're announcing that NVIDIA AI Foundry is working with some of the world's great companies. SAP generates 87% of the world's global commerce. Basically, the world runs on SAP. We run on SAP. NVIDIA and SAP are building SAP Joule co-pilots using NVIDIA NeMo and DGX Cloud. ServiceNow, they run 85% of the world's Fortune 500 companies run their people and customer service operations on ServiceNow. And they're using NVIDIA AI Foundry to build ServiceNow Assist virtual assistants. Cohesity backs up the world's data. They're sitting on a gold mine of data. Hundreds of exabytes of data, over 10,000 companies. NVIDIA AI Foundry is working with them, helping them build their Gaia generative AI agent. Snowflake is a company that stores the world's digital warehouse in the cloud and serves over 3 billion queries a day for 10,000 enterprise customers. Snowflake is working with NVIDIA AI Foundry to build copilots with NVIDIA NeMo and NIMS. NetApp, nearly half of the files in the world are stored on-prem on NetApp. NVIDIA AI Foundry is helping them build chatbots and copilots like those vector databases and retrievers with NVIDIA NeMo and NIMS. And we have a great partnership with Dell. Everybody who is building these chatbots and generative AI, when you're ready to run it, you're going to need an AI factory. And nobody is better at building end-to-end systems of very large scale for the enterprise than Dell. And so anybody, any company, every company will need to build AI factories. And it turns out that Michael is here. He's happy to take your order.
So in this section, he's kind of just flexing a bit how NVIDIA is working with all the top companies in the world to optimize their data processing, their computing, etc. And he has every right to flex. I mean, he's built NVIDIA to be one of the most valuable tech companies in the world. And so he's mentioned they're collaborating with, for example, Microsoft, SAP, Adobe, Databricks, Snowflake, etc. And he mentions these NIMs, which are basically microservices. These are services that NVIDIA provides to their enterprise customers to develop and implement custom applications on their own platforms while retaining ownership of their intellectual property. So, for example, these NIM microservices could be used for developing a company's own generative AI models, and it can also be used for like data processing and more. So, for example, there is a microservice where a company can easily deploy AI models from Google, Hugging Face, Meta, Stability, etc. You can also integrate popular AI frameworks such as DeepSet, LangChain, and Llama Index. This is getting quite technical, but just understand that NVIDIA is now launching these services called NIMs, which enable companies to basically securely integrate with NVIDIA's computing and data processing capabilities, as well as easily deploy or train models or integrate with other AI functions or frameworks that are out there.
Okay, let's talk about the next wave of robotics, the next wave of AI, robotics, physical AI. We need a simulation engine that represents the world digitally for the robot, so that the robot has a gym to go learn how to be a robot. We call that virtual world Omniverse. And the computer that runs Omniverse is called OVX. And OVX, the computer itself, is hosted in the Azure cloud. Once you connect everything together, it's insane how much productivity you can get. And it's just really, really wonderful. All of a sudden, everybody's operating on the same ground truth. You don't have to exchange data and convert data, make mistakes. Everybody is working on the same ground truth. From the design department, to the art department, the architecture department, all the way to the engineering and even the marketing department. Today we're announcing that Omniverse Cloud streams to the Vision Pro. And it is very, very strange that you walk around virtual doors when I was getting out of that car. And everybody does it. It is really, really quite amazing. Vision Pro, connected to Omniverse, portals you into Omniverse. And because all of these CAD tools and all these different design tools are now integrated and connected to Omniverse, you can have this type of workflow. Really incredible. Let's talk about robotics.
This is NVIDIA Project Groot. A general-purpose foundation model for humanoid robot learning. The Groot model takes multimodal instructions and past interactions as input and produces the next action for the robot to execute. We developed Isaac Lab, a robot learning application to train Groot on Omniverse Isaac Sim. And we scale out with Osmo, a new compute orchestration service that coordinates workflows across DGX systems for training and OVX systems for simulation. With these tools, we can train Groot in physically based simulation and transfer zero shot to the real world. The Groot model will enable a robot to learn from a handful of human demonstrations, so it can help with everyday tasks and emulate human movement just by observing us. This is made possible with NVIDIA's technologies that can understand humans from videos, train models in simulation, and ultimately deploy them directly to physical robots. Connecting Groot to a large language model even allows it to generate motions by following natural language instructions.
Hi, GL1. Can you give me a high five?
Sure thing. Let's high five.
Can you give us some cool moves?
Sure. Check this out.
All this incredible intelligence is powered by the new Jetson Thor robotics chips, designed for Groot, built for the future. With Isaac Lab, Osmo, and Groot, we're providing the building blocks for the next generation of AI-powered robotics.
About the same size. The soul of NVIDIA, the intersection of computer graphics, physics, artificial intelligence. It all came to bear at this moment. The name of that project, General Robotics 003. I know, super good. Super good. Well, I think we have some special guests. Do we? Hey guys. So I understand you guys are powered by Jetson. They're powered by Jetsons. Little Jetson robotics computers inside. They learn to walk in Isaac Sim. Ladies and gentlemen, this is orange, and this is the famous green. They are the BDX robots of Disney. Amazing Disney research. Come on, you guys, let's wrap up.
All right, there's a lot to unpack here. Next, he mentions Omniverse and the Omniverse Cloud. Now, Omniverse isn't anything new. They announced this last year, and I did a couple of videos on the Omniverse as well. It's basically a 3D representation of the real world. It's what he calls a digital twin. So it obeys all the laws of physics of the real world. And why on earth are we creating this digital twin? Well, yes, you can say it's for video game design and modeling and 3D animations, etc. But in the world of AI, you can also train these autonomous agents in these virtual environments. And what's the point of that? Well, it's because if you build out a physical robot and train it in the real world, first of all, it costs a lot of money. There's going to be hardware issues. There's going to be maintenance costs. Plus, you can't really get enough data. To train an AI properly, you need millions or even billions of iterations for the AI to learn well. So instead of running a real physical robot a billion times, it would be much cheaper if you can just put it in a virtual environment and run it through like billions of simulations. And that virtual environment, since it's basically a replicate of the real world, after it has finished training, you could, in theory, deploy that to the real world and it would work just fine. So on Monday in their GTC conference, NVIDIA announced the Omniverse Cloud, which basically provides APIs to companies so that they can kind of access these Omniverse features. Now, if you're feeling overwhelmed by all these different NVIDIA product names, well, guess what? There's more. So Jensen also mentioned NVIDIA Isaac Sim. And the Isaac Sim is a robotics simulation platform used to design, test, and train AI-based robots. It's powered by Omniverse, which we just talked about. So this is used to deliver physically accurate virtual environments for building high-fidelity simulations. high fidelity is key here. So basically this means high accuracy. You can imagine with these robots, which are often built for industrial applications, it needs to be very accurate. So here's a quick introduction on what exactly the Isaac Sim is and what it can do.
Successful development, training, and testing of complex robots for real-world applications demand high-fidelity simulation and accurate physics. Built on NVIDIA's Omniverse platform, Isaac Sim combines immersive, physically accurate, photorealistic environments with complex virtual robots. Let's look at 3 very different AI-based robots being developed by our partners using Isaac Sim. Fraunhofer IML, a technology leader in logistics, uses NVIDIA Isaac Sim for the virtual development of Obelix, a highly dynamic indoor-outdoor autonomous mobile robot, or AMR. After importing over 5,400 parts from CAD and rigging with Omniverse physics, the virtual robot moves just as deftly in simulation as it does in the real world. This not only accelerates virtual development, but also enables scaling to larger scenarios. Next, Festo, well known for industrial automation, uses Isaac Sim to develop intelligence skills for collaborative robots or cobots requiring acute awareness of their environment, human partners, and tasks. Festo uses Cortex, an Isaac Sim tool that dramatically simplifies programming cobot skills. For perception, AI models used in this task were trained using only synthetic data generated by Isaac Replicator. Finally, there's Animal, a robot dog developed by a leading robotics research group from ETH Zurich and Swiss Mile. Using end-to-end GPU-accelerated reinforcement learning, Animal, whose feet were replaced with wheels, learned to walk over urban terrain within minutes rather than weeks using NVIDIA's Isaac Gym training tool. The locomotion policy was verified in Isaac Sim and deployed on a real Animal. This is a compelling demonstration of simulator training for real-world deployment. From training perception and policies to hardware in-loop, Isaac Sim is the tool to build AI-based robots that are born in simulation to work and play in the real world.
So I hope from that video you get to understand the value of these virtual environments. It's a digital twin, so a direct replicate of the real world where these robots can train like millions of sessions and then replicate what they learned into the real world. This is a lot more cost effective than actually training a physical robot in the real world for millions of times. And finally, NVIDIA also announced Project Groot. Groot stands for Generalist Robot 00 Technology. Groot is basically a general-purpose foundation model for humanoid robots. A foundation model, you can think of it as an AI agent that's able to act autonomously and learn from its surrounding environment with minimal guidance. So this concept of foundation models actually isn't new. Around a month ago, Dr. Jim Fan from NVIDIA announced these foundation models, which they're actually training in video games. And so you can see this foundation model is learning how to play Minecraft by itself. It's learning all these skills like how to swim, how to gather resources, how to catch fish, all by itself. And eventually, it learns how to build these really beautiful worlds in Minecraft. Here you can see NVIDIA training another foundation model to do various tasks millions of times in this simulated environment. And NVIDIA is not the only company that's training these foundation models using video games and virtual environments. So Google recently released Sima, which they're also training to pretty much learn by themselves how to play all these games from like Wobbly Life, Teardown, Construction Lab, and even Goat Simulator 3. And again, why they're doing this isn't just so they can train an AI that's going to be good at video games. They're doing this because they want to train an AI that can be able to learn across different environments and then eventually take that AI and deploy it in the real world. And so this Project Groot is also a foundation model that's built specifically for humanoid robots. They also unveiled a new computer called the Jetson Thor, which is for humanoid robots. They mentioned that the Jetson Thor is capable of performing complex tasks and interacting safely and naturally with people and machines. I sure hope that it does interact quote-unquote safely with humans. So you can see Project Groot is a foundation model that takes all of these task prompts and then they're training this Groot in these virtual environments to walk on different terrains, walk on two legs, and how to balance properly. So after like thousands to millions of iterations, basically Project Groot is the foundation model behind all of this, and it can take in text data, video data, real robot data, and you train this in NVIDIA's Isaac simulated environment, and eventually you plug this into a humanoid robot, and in theory it should work accurately in the real world as well. So here you can see some examples where on the left, this is the robot that is trained in the virtual environment, and here's the real robot in real life. And you can see it's doing the exact same task as in a virtual environment to show that, yes, you can just train this virtually and deploy it accurately in real life. Here you can see the robot is trained by human demonstration. This is also called teleoperation. So it first mimics how a human would do the activity. So the human is kind of teleoperating it. It would learn from a human demonstrating how to do the task first. Here's another example where it's copying the movements of this woman. It's basically just tracking the movements of her limbs through video input. And then it's training this action in the Isaac Sim, this virtual environment, again for a lot of iterations. And then you deploy this trained model into the real world, and it's able to execute this action perfectly. And finally, they showcased these droids that are trained in collaboration with Disney, which, by the way, don't you think they are very cute? I just think the noises that they make and just the way they walk, it's really cute. So these droids, they learned to walk and balance on two legs, all in the Isaac Sim virtual environment. They went through tons of rounds of reinforcement learning before they were deployed in the real world. And you can see they were able to balance properly and walk around without any issues in real life as well. And these droids are powered by Jetson Thor. Again, Jetson Thor is the computer that NVIDIA just announced for humanoid robots. So that covers the main points that Jensen mentioned in the previous clip. Now let's move on to his conclusion.
This is what we announced to you today. This is Blackwell. This is the platform. Amazing processors, NVLink switches, networking systems, and the system design is a miracle. This is Blackwell, and this to me is what a GPU looks like in my mind.
So there you have it. It's important to note that NVIDIA is not just a chip company. They're building an entire ecosystem to help companies process data, to optimize computing, to help them deploy and build their own AI models, and also to help companies train humanoid robots in a virtual environment, and then eventually deploy it in the real world. They have a lot more going on than just, building GPUs, which they're historically known for. It's also important to note that NVIDIA is not the only player in this. Their close competitor, AMD, is also building cutting-edge chips for AI applications. Intel is also building some processors and chips specifically for AI. So they are also a competitor in this. I would say NVIDIA is still the leader in all of this. They have the most market share, but they're not the only ones doing this. Another thing to note is that top tech companies like Amazon are also building their own AI chips because there's such a shortage of these NVIDIA H100 chips, which, as I mentioned in the beginning of the video, they are in such high demand that they are reportedly sold out until 2024. So instead of just waiting for these chips to be available, Amazon is producing their own AI chips as well. Google has also always been producing its own tensor processing units, which are also specifically designed for AI applications. All in all, especially going back to this chart where they show how compute power has increased over 1,000 times compared to 8 years ago, you can see things are going to get really, really wild. We are in the middle of an AI revolution, and we're going to see AGI pretty soon. So with this announcement of this Blackwell platform, AI systems and applications that we know today, and these humanoid robots that we know today are going to improve like orders of magnitude in a very short amount of time. Things are going to improve really quickly. I wouldn't be surprised if at the end of the year, we would have general purpose humanoid robots inside our homes helping us do chores and other tasks. It's a really exciting time to be alive. So let me know in the comments what you think of these product announcements. Do you think this is just an overhyped thing, or do you think this is world-changing? If you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, we built a site where you can find AI tools and apps, and also look for jobs in AI, machine learning, data science, and more. So check that out at ai-search.io. I'll see you in the next one.